Okay.
Can you tell us your name and tell us about your project?
Well, I am Sir Harrison Sims, colleague of Sir Arthur Eddington. We made a trip to the island of Principe in order to view the eclipse that took place on May 29th, 1919. During this time, we observed how the light from the Hyades star cluster passed through the sun's gravity field. We knew that light from the Hyades star cluster would have to pass through the sun's gravitational field during this eclipse. We took and compared pictures of the eclipse versus pictures of the stars normally. This was to see if the sun's gravitational field would influence the light passing from the Hyades star cluster. The solar eclipse allowed for us to measure the stars with the gravity shifted position. We measured the positions of the stars normally, then we compared it to the position through the sun's gravitational lens.
Okay. Well, what were you guys trying to do or find?
Well, our main goal was we were trying to see the gravity, if it would affect the light behind it passing towards us. By noting the changes caused by the gravity field, we were able to prove Einstein's general theory of relativity. And see if it was accurate based on the gravitational fields that would cause the warps in space-time. Seeing the difference from the positions of the stars normally, then when compared to the eclipse pictures, or to the positions during the eclipse, the pictures from the stars from a regular night compared to the picture had gaps, and that was caused by the bending of light, which was caused by the gravity of the sun. This proved that the gravity fields affect light travel, as the light that we observed was warped slightly around the sun and would later to become known as gravitational lensing. This warp proved Albert Einstein's was correct in his theory of relativity.
Where did the project or experiment occur?
We actually had two groups doing the experiment, as we were worried that bad weather and other conditions would keep us from seeing the eclipse when it occurred. We had one group that I was with that went to the island of Principe, which is a small island laying off the coast of Africa in the Gulf of Guinea, where we took many pictures of the eclipse carrying in telescopes, cameras, and much more equipment. And the other group was sent to Sorbal, Brazil, in hope that they would have an agreeable weather if we didn't.
Okay. What other significant events were happening around the world at that time?
Well, around this time, World War I had just ended and the League of Nations was just newly forming. Woodrow Wilson had just recently won a Nobel Peace Prize, and the 19th Amendment to the Constitution was just passed, giving women the right to vote.
Who else was involved in the project?
Before the experiment, Willem de Sitter sent me numerous letters and papers detailing Einstein's new general theory of relativity, making me familiar with his work and honestly making me a big fan of it. Sir Frank Watson Dyson, Astronomer Royal of Britain, had proposed expeditions to Brazil and Principe to determine if Newton or Einstein was more accurate about light bending in a gravitational field. This expedition was also backed by the Royal Astronomical Society.
What was your role in the project?
My main role in the project was to travel to Principe, map out the star's locations before the eclipse, and then measure the space-time deflection of the starlight during the eclipse. I was one of the few people in the entire world that would be able to perform these calculations.
Well, what impact did your project have on the physics community?
The main impact of this experiment was proving Albert Einstein's general theory of relativity. This was a huge shift from Newton's theory to Einstein's theory of relativity, which predicted half of the deflection that actually occurred. Many scientists favored Newton's theory over Einstein's due to the fact that at this point, Newton was more credible, and there was a general mistrust of German scientists due to the fact that World War I had just ended. This gave a larger understanding of how light traveled and the state of relativity. This not only gave more credibility to Einstein's work, but it made him a more prominent figure in the scientific community.
All right. Well, what were some of the problems that you faced during this experiment?
There weren't a lot of problems except for two main ones. The first problem was that Sir Arthur Eddington was called to serve in the military before the expedition even began. He had to appeal to multiple courts, telling them about the importance of the experiment and his role that he had to play in it. And he had to convince them that he should be allowed to go. During the expedition, in Principe, it had rained for 2 weeks prior to the eclipse and during the day of the eclipse. This was one of the reasons that we sent 2 groups to 2 different locations. Many of us were worried that we weren't actually going to see the eclipse at all. Eventually, a few minutes before the eclipse actually happened, the clouds dispersed and we were able to conduct our experiment and get all the accurate measurements. The group in Brazil didn't have to deal with any weather issues, but they had trouble with the heat in Brazil. The high temperature would cause the metal to warp in the telescopes, but luckily they had smaller telescopes on hand that remained relatively unaffected.
Okay, thank you.